Welcome to this week's Focus on Geothermal Energy for the Weekend webinar with Think Energy and EnerChange. With us today, my name is Alexander Richter. I'm the editor, the founder of Think Energy. And with me today is Hermann Röhm, the head of global power applications at German company ORCAN Energy, an ORC company providing modular ORC solutions globally for the waste energy space, but also for geothermal. Very pleased to have him on board today to give a presentation on the flexible electricity generation from geothermal heat with ORC. You will have the opportunity to ask questions that will be answered after the presentation in the dashboard of the webinar. You can ask these questions. We will then group and put them forward to the presenter after the presentation. And with that, over to you, Hermann, for your presentation.
So thanks, Alexander, for the kind introduction and a very warm welcome from ORCAN Energy to everybody joining here on this Friday afternoon. So our today's subject is flexible electricity generation from geothermal heat with modular ORC solutions. And let me just proceed. Yes, now it works. So before we dig into the details of our today's subject, I just want to show you two slides about ORCAN. So the first slide here is about a project with 70 of our energy modules or efficiency packs, which we have executed in 2018. It's actually a gas power station with 70 of our ORC modules. Why I'm showing this here, a geothermal session, reason is very simple. It shall simply illustrate that we can basically add as many units as we want and as the customer requires. And just to add, in 2019, we even received another order from the same client with 160 units at one site. So you can see this is definitely a scalable solution, and you will see later on why it's important as well for geothermal applications. And on that slide, I just want to illustrate our core product currently for the global markets. It's the so-called efficiency pack 150.200. That means the maximum possible net electricity varies between 150 to 200 kilowatts. And it is installed in a 40-foot container. So, and you can also see here, you can simply put it on a truck and ship it to the sites. And especially in remote areas, it can be very attractive to ship the containers like that to sites, and that allows relatively easy installation later on. And what we offer is a kind of plug and play solution. So each container can be basically connected within 1 day. The weight is only 14 tons, and you can see on the left and right hand side the integrated air coolers, and as said, in a compact 40-foot container. And so basically per year we do need about 1 day of maintenance work, or rather scheduled maintenance work. Is further characterized by an autonomous operation and also very important, no consumables. And our media used for the operation is non-flammable, and every single unit is factory tested before it leaves our factory. That is a very simple slide, just illustrating that usually any geothermal source will provide a stable heat supply over time. And in the next slide, you will see that the heat demand usually, and especially in countries where you do see summer and winter time, the heat demand is fluctuating a lot over time and over the year. So usually in summertime, when it's hot outside, you do need less thermal heat, for example, for district heating, heating of greenhouses or whatsoever. And so what happens if you only would make use of the thermal heat for any heating purposes? You would waste the residual heat. And in here it is somehow illustrated that the blue line is the heat demand from a typical district heating system. And the red part would be the wasted energy, because you would need to re-inject the thermal brine, or the brine, at a relatively high temperature. And about 5 years back, ORCAN asked what could we do and how could we offer flexible solutions to make use of this until then this partly wasted energy. And we decided to develop the efficiency pack I showed you in the beginning, so the 200 kilowatt modules. And depending on the available and residual heat, you can use as many as you want and as many as you can operate, basically. Now, in here it is illustrated. If you would use only one ORC, then typically there's still residual heat available, but relatively easy, illustrated here. If you add a second one, or even a third one, or further a fourth one, so you can adjust it accordingly and make use of all the heat. And maybe just to add, we do not see only fluctuations over the year or over months, but as well in daily operations. So it can be even in summertime relatively cold days, so then there's not enough heat available for 4 units, for example, and then we could simply only operate 3. So we are definitely highly flexible, and also most important, fully autonomous, or autonomously. The units can be switched on or switched off. And on that slide, let me start in the center, where you can see in that case 6 efficiency packs. And maybe that is just for reference, about 6 units. You can assume that you can generate about 1 megawatt of electricity. Of course, it is always depending on the temperature and the volume flow of the well. And but that is always, we always look into it individually, what would be the power which can be generated. And our solution generally looks like that. So you have the ORCs, and the energy will be transported to the ORCs with a hot water loop. And if you go left, you can see the illustrated heat exchanger. And for every geothermal project, we will design an individual heat exchanger which fits exactly to the requirements of the projects. So first of all, we need to look at the brine quality of the contents. We need to check the risk for scaling within the heat exchanger, and all these things I think well known to you already. And yeah, with that, going further left to the wellhead or the geofluid and the hot water are completely separated. So that gives us the advantage that we will not feed any of the geofluid, which can be very aggressive, into the ORC itself. So the major maintenance requirements, therefore, will happen outside the ORC systems within the heat exchanger. And we always design the heat exchanger system in a way that you can do easy maintenance, be it by means of plate core heat exchangers or shell and tube heat exchangers. But maintenance always is a very important aspect. So in case of scaling happens, this can be fixed easily. Then let us quickly move to the right-hand side of the slide. Here you can see on the top parallel configuration, and on the lower part series configuration of our ORCs. And in every project we will check what will be the best solution, either many units in parallel configuration or in series configuration, or it can be a combination of both. And the purpose for that is that we always either try to get the highest efficiency or the highest electrical output from our ORCs. And this is on the one hand side, depending on the client's needs or on the feed-in tariffs. So for each and every project, we will check that for our clients or do this exercise jointly. Now let's have a look on our geothermal reference project in Germany. Sure, some of you may have even visited in Kirchweihbach near Munich. And the initial situation was that the project had to be realized in a very short time period. And it was well known, as described before, that there will be high fluctuations in the heat demand. The reason for that is that the major purpose of the hot brine is for heating nearby greenhouses, where mainly tomatoes are grown and they are for the use in the region around Munich. And then there's another district heating system for nearby housing complexes. And the third part is generating electricity with the residual heat from the brine. And initially we installed 6 units of our EP150-200, and the net power output is about 640 kilowatts electrical. And then what happened later on, there was more heat required for heating of the greenhouse than the district heating system. And there was simply not enough heat available for the 6 units anymore. And so we decided together with the client and that we will remove 3 of our ORCs. So today, if you would visit the plant, you would see only 3 units left. And the other 3 units we sold to other clients. And that was actually no problem at all. And so today, there are 3 units still there. And if more heat should be available in future, you can also do it vice versa and add another 1, 2, 3 units depending on the residual heat. Here you just get a glimpse and impression of the site in Kirchweihbach. So on the left-hand side still, you can see the 6 units installed, and on the right-hand side is during installation, the upper part, you can see we just put the ORC units by using a crane into the foundation, and that happens within less than a day to put them into the foundation. Then, of course, subsequently to do the installation for the all the racks and the hot water pipes, that takes slightly longer, a couple of days or to a few weeks. Maybe in Europe, important to know, of course, you have to do proper insulation, heat insulation for all the hot water pipes. So it's maybe a bit more complex than if you would do it in a hot country where insulation is not that sensitive. And maybe just to summarize that project, so with the initial 6 units, we produced a 640 kilowatt electrical net, then approximately 4 gigawatt hours of electricity saving per year. Now another project, the application itself
just quickly, could I just quickly jump in? Could I just quickly jump in? We might have some microphone issues here. You're breaking up a little bit. Could you maybe just check that your microphone is plugged in correctly, and just to make sure?
But is it better now again?
Yeah, let's try. So you've just been breaking up a little bit. So let's continue.
Okay, sorry for that. So then I just repeat. So that's a project in Austria. The company is called Frutura, and they are producing fruits and vegetables in their greenhouse. And so it's a similar application like in Kirchweida. So heat is mainly used for heating of the greenhouse, but although same story, the residual heat is used to produce electricity. And in that case, there was only enough heat for 1 unit currently. And with that, we are producing about 125 kilowatts electrical. And this amounts to 625 megawatt hour per year and about 100 tons of carbon dioxide savings per year. And then let's switch to the other part of the world, to Taiwan. So we have received 2 orders. Actually, both sites are next to each other. So therefore we combine it here on one slide. And each project generates about 1 megawatt electrical power. And in that case, we are using our water-cooled units because for the client it was very important to save space, and therefore they decided to go for the water-cooled units. So in the 40-foot container, which you can see on the bottom, 3 of our 150-200 units are installed, but water-cooled, therefore you won't see the radiators. Okay. And then last but not least, together with Baseload Capital and Chevron, we have done a prototype project in the oil and gas sector, geothermal application in the oil and gas sector in US. And it is also 1 unit of the 150-200 at an existing oil well. So the heat is used from the water, which is part of the oil production. And the location is in California. And yeah, that's also, I think, quite interesting application. And while we speak, we have already executed another project similar to that in US with another client, and we believe more to come. So then let me quickly summarize. So all our solutions are economical. That is, we are always focusing on, and you can usually achieve fast savings. And maybe one aspect, what I haven't mentioned yet, it's not so much technical, more commercial. Besides our sales of the ORCs, we can also offer to our clients finance solutions. So that means if required, we can even do PPA agreements, but of course that is always a tailor-made solution, and this needs to be discussed with the clients. Then talked about the modular design and all the low operating costs, because there are basically no consumables, autonomous operation, and very limited maintenance time. Talked about flexibility. So you can use various waste heat sources, or in geothermal, of course, it's not waste heat. In geothermal, it is the main purpose to use the heat from the well. You can offer a wide temperature range from 80 to 150 degrees Celsius. And also we can offer excellent part load capabilities of each individual unit. And last but not least, robust design. Talk about fast installation and then high utilization rate, and most important, secure operation. And to conclude, just about ORCAN in a nutshell. Founded in 2008, meanwhile more than 60 employees. We are growing quite tremendously, and we have over 600 units sold, accumulated more than 7 million of operation hours, and already saved over 150,000 tons of carbon dioxide. And yeah, together with you, with our clients, that's our mission to grow not only in the geothermal markets, but also in other applications. And yeah, with that, I would close the presentation, and if there are any questions, happy to answer them. Thank you.
Thank you very much for a really kind of inspiring kind of presentation on the ORC units here provided by ORCAN. I think I personally have always been quite intrigued by these smaller units and the opportunities it presents. So it's fantastic, and of course that based on that, I have probably quite a few business development kind of questions in that context. But maybe to start with some questions here from the audience that came in. And I guess they come down to the classic question, I guess, for these smaller ORC units or ORC units at all. Kind of what is the minimum temperature that you would be able to utilize for power generation with your units?
Yeah. Okay, as I mentioned at the very end of the presentation, so the minimum temperature is 80 degrees Celsius, so that it, from a technical point of view, can work. That means we would produce more net power than the ORC units consumes itself. But I want to be very open here. It really depends on the ambient temperature. So in a hot country, in the tropics, for example, it should be rather in the range of 100 degrees, because by physical law, the efficiency, of course, is much higher if the temperature would rise, if the brine temperature rises, so if the ambient temperatures are high.
Yeah, so the cooling, I assume, is then the issue here.
Yeah, and maybe just to add one thing, of course, I also showed one slide that we do have water-cooled solutions. So if in hot countries cooling water is available from whatever source, ideally in the range of 25 degrees Celsius, then of course you can avoid the big impact from the ambient temperature. But that is always a question. I mean, in geothermal applications, usually, especially in remote areas, you would not find cold water, at least not in the tropics. If you go, for example, to Iceland, there, of course, you can find cold water, and so then you would be fully independent from the ambient temperature.
Yeah, I guess in a nutshell, it is as colder as the climate is, the more efficient and the lower the temperatures you can utilize.
Yes.
There's also a question, and of course that is a question that people kind of often can't answer in detail, but the required flow rate, in a sense of kind of how much fluid do you need to, let's say, somewhat economically produce electricity with your unit?
The bare minimum for a single unit would be in the range of 60-65 cubic meters per hour. And then you can operate one of our 150-200 units. And of course, the net output again is depending also on the temperature. So if it's 80 degrees, then you would be at the very low end of the net output. If it's 150 degrees prime temperature, then you would get closer to the 200 kilowatts. So again, 65 cubic meters would be the bare minimum, and then you can add the more volume flow is available, you can add more units.
Yeah. I guess then also kind of maybe staying to maybe a more general question in a sense of overall market size. I mean, we understand that the waste heat market is huge, and there's a lot of untapped potential, and also I guess geographically kind of like way more open than geothermal. But how do you see the opportunities for ORCAN in that sense, and kind of how much kind of in percentage would you see geothermal play a role for your business going forward?
I mean, currently geothermal, not only in Europe but also in Asia, plays more and more important role. So to give you a clear percentage is a bit difficult for the simple reason, as you all know, geothermal project needs very long development time. Just until to get the well in place takes sometimes years, and of course you can only execute the project once the well is in place usually. So but definitely geothermal plays a more and more important role for ORCAN, and yeah, basically all over the world. Let's start in US. I showed you some examples, more to come. Then Europe, definitely. Currently, we also do see even bigger projects compared to what I showed in Kirchweiler or in Austria. And then Asia, definitely as well. We received the first order. We are working on many more projects. So it plays a really vital role.
Okay. Then here another question with regards to let's say the waste heat. The question kind of from I mean the classic I guess waste heat productions are let's say industrial waste heat, like from any kind of heat created in industrial processes. But but how about with hot exhausted gas from combustion machines? Kind of, do you see what's your take on that for your machines?
I mean, the very first slide I shared today, these are gas engines, so gas power plant based on 1.5 megawatt gas engines. So we have demonstrated that this works perfectly well. Although just right now I'm still in France, and we had an inauguration of a biogas plant yesterday here in France at our client site. So that is even the application where ORCAN grew in the very beginning. So the first applications were biogas applications in Germany. So clearly, yes, that works perfectly well. and not only with reciprocating engines, but as well as with small to medium-sized gas turbines. So at the end of the day, we don't really care where the heat is derived from, because I explained it for geothermal applications, but at the end of the day, for all other applications would be the same. We are always using a tailor-made external heat exchanger, so we can adapt it to the heat source. And maybe one last point regarding engine applications. So biogas can be very aggressive, so therefore you need to design the heat exchanger in stainless steel. For example, for diesel, standard steel will do the job, and then closing the loop to geothermal again. In geothermal, we can either use the highest grade titanium built heat exchangers, or if it's a very simple non-aggressive brine, we can use other standard steel or stainless steel, whatever is required for the external heat exchanger.
Okay. Here, a very specific question, and of course it's up to you to answer, but what technology are you using for the expander, and what is the isentropic efficiency?
The technology is based on twin screw expanders. So it's derived from the refrigeration industry. We are just not using it as a compressor. We are using it the other way around as an expander. So of course we have done some modifications for that. And regarding the efficiency, I don't want to disclose it here. That would be something we need to discuss individually, but our contact details are there, so happy to go into personal talks.
Fair enough. Practical question here. I mean, I assume that kind of with the way you described it, that you're also providing some vendor financing, so you'll be able to finance this. But here the question is, like, would you also be, open to renting this solution, let's say for a set period of time?
Yes, generally yes. However, we need to, of course, look into details then of the project. How long it would be. I'll just give you one extreme example. For 1 or 2 months would not make sense. For a couple of years, yes, sure, we can do that. But this requires further discussion. But yeah, we can do that. And we are even some clients, maybe just to add, we are encouraging them if they are concerned and don't know how long a well, if we are talking about geothermal applications, how long a well will provide the thermal heat as calculated and predicted, then we are encouraging them to go for rented solutions.
I mean, and this puts me to I guess a question that I think we've had in the industry for quite some time. In, let's say, a stage development of a large project, let's say in Asia or Africa, and the idea is to have, let's say, a mobile unit that you can kind of start producing electricity right away from one well and then move it to another well going forward. Is that something that you are seeing as an option, or how flexible actually are these units in that sense? I mean, the understanding that I've had is that actually you really need to specify kind of exactly what temperature and what flow rates you have for the unit, or how flexible is that for something kind of more flexible like that?
Okay. I try to keep it as simple, because as usual, always demo is in the detail. But overall, the container, the ORC container, is very flexible, and as long as the temperature range is at least similar, then you can use the ORC containers at different sites. And you have seen transportation is easy, installation and also recommissioning, that is all easy. The focus needs to be on the external heat exchanger again. So if you could reuse this heat exchanger, pretty much depends whether there is a fit in the prime. First of all, volume flow, temperature, pressure levels, steam, no steam, all these kind of things. So that needs to be evaluated. But for the ORC itself, not a problem. Maybe some limitations would be 50, 60 hertz countries. If we talk about different countries, could be a challenge. Still, we can do the modifications. It's not a really big deal, but these are things you need to look into. But as long as the temperature level is in a similar range, then really no problem. And just coming back to Kirchweiler, I mean, we have demonstrated that it works. We have all of these 3 units. They have been resold in a few weeks. They were gone immediately. That's really not a big deal. And you can either resell or reuse somewhere. If it's a bigger client, then definitely it can be reused, yes.
And then maybe here kind of a very quick question, but I mean, you mentioned 80 degrees as a lowest temperature situation, but kind of what's the highest temperature you've been using with your system so far?
So the highest temperature we can directly make use of is in the range of 150 degrees. However, we have plenty of applications in place, and talking about engines. The exhaust gas is in the range of 500 to 600 degrees Celsius. Then we just adopt the heat exchanger accordingly and generate 150 degrees. The ideal temperature is always 140 to 150 degrees Celsius within the hot water loop. But even in applications with several hundred degrees, you can always adjust it with the external heat exchanger.
Okay. Regarding the working fluid, do you have is that open? Is it a specific fluid, or is it something relatively standard that you're using?
It is a standard fluid from the refrigeration sector. So I wouldn't say it's top secret. With our clients, of course, do know. But we are also not always using the same one. We can adapt it accordingly to the needs. So the major difference is for lower temperatures, we are using a different fluid compared to higher temperature levels. And that is always the purpose for that is always to optimize the net power output of the ORC unit. But I would prefer to discuss it then with potential clients individually.
Okay, that's not quite sure if the general temperatures play a role in this, but here's the question: if there's a minimum outlet and inlet temperature for the turbine itself.
Of course, and at the end, yes, it is. I mean, let's say the inlet temperature, the maximum is in the range of 140 and 150 degrees, what I just mentioned. That is the maximum temperature we can make use of. But how we deal with it, let's say if there's more energy available, we can simply add more units and generate more volume flow at 140, 150 degrees.
Okay.
But of course, this inlet temperature for the expander is also depending on the working fluid we are using. Mm-hmm. So it's different for low temperature applications compared to high temperature applications.
Okay. Going through a few more questions here. The minimum load you might run on the module, so part load capacity.
I would say it's in the net output would be in the range of maybe for the 150-200 module would be maybe 50 kilowatt. That is still possible. So you can really go, or even lower. But again, a bit depending on the ambient temperature. If it's extremely hot, then the machine would stop earlier. So, but we always control, and that is basically the guiding principle. There still needs to be net output possible. Only then we would operate the system.
Okay.
So under ideal circumstances, it can go even below the 50 kilowatts, but I just gave you as a rough indication.
Going through further here, what is the lowest and highest efficiency in terms of the heat energy conversion to electricity, and how much does it vary with the fluid temperatures?
The highest efficiency is in the range of 10% for electricity, and the lowest it can drop basically close to zero. And related to what I just explained, if the brine temperature, if we are talking about geothermal applications, if the brine temperature is very low and the ambient temperature very high, then of course the efficiency drops significantly. But the goal is always, especially in geothermal applications, to avoid such a point of operation. You would always try to go to the optimum levels in the range of 10%.
Okay. Of course, this is always the classical question. So how much does it cost? And I know that this is a question that you likely will not be able to answer because it depends. But essentially, from a market perspective, I mean, we understand that markets that say that have high electricity targets or tariffs are probably more favorable for, let's say, in this case, probably more costly electricity generation than for example, wind. But what would be your standard answer to this question of the cost versus the electricity price that could be achieved?
Yeah, I want to give a standard answer indeed, because it can vary really a lot. Again, depending on all the auxiliary equipment needed, and for us, it's mainly the heat exchanger that can be just in the range from, in the easiest case, let's say 10-20% of the ORC costs for the auxiliary equipment, up to more than 100% in a very complex, high temperature, dusty application. So there's a big range, and of course you need to add this to the pure ORC costs. But what I can definitely say, we are in the range of even bigger ORC power plants, so euro per kilowatt, we can match absolutely, and also we can match or at least get close to solar PV prices in that range. Somehow we are as well, and let's say I guess clients wouldn't do this and use the units if we wouldn't be competitive in a way. But also again, details needs to be discussed project specific.
But in this context, maybe then also practically, kind of in the sense of, let's say, the customer engaging with you on a setup of a unit, the package that you provide, essentially, you're selling the unit, you deliver it on site, or you design it basically based on the details of the wells or the energy that you have available, and you deliver it on site, you set it up. Kind of how far, let's say, kind of how much is part of the package that you offer, and do you, because that's then also the question here, do you also have a model where you actually operate it for the client?
So again, fully project depending, we can either simply supply the ORCs, or we can do even a turnkey solution. So both is possible, but then of course, depending on the country, then we would use local EPC companies and do the job at site together with them. So we would never supply everything out of Germany into Asia, for example. So we would have local partner companies to do the on-site execution. But it's really the full spread is possible from the pure ORC delivery up to turnkey solutions.
Yeah, so I mean, I guess this is partly like similar to what I asked before, but it's the question here of a long-term lease arrangement as part of the financing. Is that something that you would do? So the companies would avoid the upfront capital and maintenance cost?
Yes, absolutely yes. Even 15 years is not an issue. In some cases, we are even discussing solutions up to 20 years. But of course, I want to highlight, then we need to do a due diligence with the client, and such details needs to be discussed. But yes, it's possible.
Now, and again, I mean, I don't know how much you want to share on that, but here's the question, of course, kind of how many units are you manufacturing per year? But what would be the typical project, let's say, lead time from the engagement to, let's say, a unit can be up and running at the client?
I mean, some of you might have read in the press end of last year that we have invested in a bigger factory in Kiel in Germany, and currently no limits in production. A couple of 100 units per year would be easily possible. Of course, you need, if you talk about high numbers, you need a certain ramp-up time to get the parts, to have the staff there, but the space is there. We can do that. And yeah, having nothing to add, then talking about lead time, a typical lead time for the ORCs itself is roughly 6 months. Let's talk about 6 units. You can certainly get within 6 months because the units are standardized. We usually keep stock on our parts so that we can ensure relatively short lead times. And of course, if you want to order more units, then we would deliver them gradually, but up to 10, 20 units per month. If we do have a certain time to get prepared and have the parts in the factory, is definitely possible.
Okay, the question here, if the equipment has been utilized, deployed in the US, I think that you answered already with baseload and the project with Chevron.
Yeah.
But kind of how many units in the geothermal space have you installed so far?
Installed about 10-ish roughly, which are really installed, but we have already manufactured quite a number which are now due to be delivered. So you will see increase of numbers very shortly. Unfortunately, I cannot talk about all the details of those projects yet, but you will see many more units in the field in the near future. But maybe just adding to the question on US, of course, in US we do have UL requirements, and our units can be fully UL certified. So we are doing this in the factory in Germany currently, and the officers from the certification agency are coming to our factory, do all the required checks so that we can ship the units fully certified.
Yeah. This is here comes a good question as well. I mean, which is kind of also, I guess, very interesting. Let's say for anyone considering, let's say, smaller scale ORC versus, let's say, conventional larger scale ORC units available on the market. Kind of what's the economy of scale and the maximum number of units which allows still a lower cost in respect to the, let's say, traditional larger scale ORC, or is there kind of some kind of ballpark figure that you might have?
There is not a black and white figure, because it simply depends on the local and project requirements. So I can give you a figure of a project we are currently working on. So these are 60 units in geothermal application, and the client decided that he would prefer still the flexible modular approach over the single turbine approach. And then we are talking about roughly 10 megawatt of this project. So yeah, 60 units is not the end. I mean, we demonstrated you could use more, but then of course you need to decide project specific what makes sense.
But I guess, like you said, I mean, the flexibility here to decrease the size and maybe use it elsewhere is something that is then, you know, advantageous compared to a larger scale, let's say, ORC.
Exactly. And one big advantage of the modular approach is that you can de-risk geothermal projects. But if you're not sure about the long-term heat supply of a well, then yeah, you could adjust numbers later on in both directions. As I explained, you can reduce the numbers if you have ordered too many, or you can add additional units, which of course for a single turbine unit is challenging. But in the contrary, I mean, we wouldn't do, let's say, a 50 megawatt project where you're using single turbine ORCs. That's very obvious.
Just when I was getting to the last question, more trickling in, but you mentioned the opportunity of utilizing ORC units in the connection with heat production. So let's say district heating, for example. The question here, of course, is kind of if you do that, you're moving a unit kind of into urban areas. So the question here is kind of, is there a certain noise emission kind of range that your units have that should be considered in the deployment?
Yes, of course there is, and especially if there are houses nearby, then potentially you need to take special measures. And just one example, in Kirchweihbach, there is a wall installed around our ORC units. And I mean, if you are outside this wall, you can hardly hear the ORCs. Although I'm just actually sitting next to the running ORC. If I open the window, then you can hear it. If it's closed, you can hardly hear it. So in 1 meter, it's about in the range of 90 dBs, just as an indication. Again, it is a bit depending on the ambient temperatures, because if the fans are running at full load, then of course you have more noise emission. If it's cold outside, you have significantly less noise emissions. But that is always something we check with our clients, what are the specific needs. But so far we always found a solution, and I couldn't remember any project where noise would have been a hindering reason to execute the project.
Okay, fair enough. And I think with that, I think I come down to the last question. And of course, here's a specific competitor of yours mentioned, but the question is, like, if you were in a few words kind of, you know, describe kind of your your position towards other competitors in the ORC market, and kind of what your advantages is. And I think with that we can leave it.
Yeah, thanks for that question. So with our modular approach, and I mentioned it before, but I think this is really important, especially for geothermal application. We are in the position to de-risk projects, and of course, if we compare it with single turbine applications, we cannot achieve exactly the same efficiencies, but at the end of the day, the client needs to decide what is more important. I mean, you cannot get everything from the wish list, but I think really experience over the last couple of years show with more than 600 units in the field, it is a solution which fits to the market needs. And we started our geothermal journey about 5 years back, and to conclude, more to come. So,
Excellent. Well, I think we're coming here to an end. I think most of the questions, I think we've answered all the questions in the system here, and some more. I would like to thank you very much for taking the time today to present on your company and your solutions. They're definitely super interesting, and of course, in the context of Think Geoenergy, would of course be very, very pleased to add all of your geothermal plants to our global geothermal power plant map, if you're able to share. But we'll be in touch on that. But otherwise, great to hear also your involvement in the geothermal sector. Thank you so much for presenting today, and yeah, thank you. And I think for everybody else, have a fantastic weekend. And with that, I think we're ending the webinar.
So thanks everybody. Thanks, Alexander. Speak soon.
Thank you. Bye-bye.